Hey everybody, this is the video about what is a bearing of a line. So what we're going to discuss in this video is we're going to discuss, hey, what is this? What does South 45 East mean? If you see it, would you be able to draw the correct line? And bearings of a line are used mostly in navigation, also in surveying. So would you understand what this was? If I said it, could you draw it? And if it was, enveloped in some sort of navigation scenario, could you find solutions to that problem? So we're going to go over two examples as well as the definition, and we're going to do some drawing. So definition, the bearing of a line is an acute angle. So emphasis on acute here, because it's got to be less than 90. Formed from the north-south line. So this is the north-south line right here. So all of our angles are either going to start in this north line or going to start on this south line. And in the direction of either east or west. So yes, bearings of a line do hinge on you knowing north, east, south, west, like the directions and how to label those on the axes. But you can use my acronym. I think it's an old one. I use never eat soggy waffles. And literally that's how I even built this. Is like, okay, never eat soggy waffles. So hopefully that'll help you keep it straight. So let's look at a couple examples. So let's say that I'm looking for the line, let's say north 45 east. I say that's the bearing of my line, my ship, my whatever. So how do I draw this? Okay, well the N here, you're always going to have an N or an S first. And that tells you, hey, start with the north line or start with the south line. So this tells me I'm starting with the north line. And then it tells me I'm making an angle of 45 degrees. Now I can make the angle of 45 degrees either to the right or to the left, right? So I need a little bit more instruction. And that's where the east comes in. So this literally translates to go to the north line, make an angle of 45 degrees, and everything's coming out of the origin. Make an angle of 45 degrees in the east direction. So there's north 45 east, right, where this is like 45 degrees here. So north says we're opening from the north line. 45 tells us how much we're opening, and east tells us in what direction, either right or left. Okay, let's look at another one. What if I said, let's do something from the south. What if I said south 10 degrees west? Okay, well the south cues you in, okay, well I'm using the south line. I'm going to start from the south line, and I'm going to go 10 degrees. Remember, everything's going to start from this origin here. Now I'm going to go 10 degrees, but I could go 10 degrees left or I could go 10 degrees right. Well, this says go 10 degrees, but go in the west direction. Well, west is left from this angle. So 10, which is very small. So I go 10 tiny degrees. And then this line juts out that way. So it tells me the direction of where this line is kind of going in space. And one more example just to close it up. Let's say north 25 degrees west. Okay, I go from my north line, I go 25 degrees, which is about that many, and I'm going in the west direction. Now I know that this angle here is 25. Sorry, that's really thick, but that's 25. Okay, that's going to be valuable information moving forward. So to recap, you're either going to have a north or a south here, and then you're going to have a degree amount, and then you're either going to have a west or an east here. And again, it just tells you, hey, start from the north or start from the south, go that many degrees, and if it's west, then you're going to the left, and if it's east, you're going to the right. Okay? Now let's see some examples of how this is going to be used. So if we have a tree on one side of a river is due west of a rock on the other side of a river. From a stake, 19.0, they're giving us significant digits now, yards north of the rock, the bearing of the tree is south 19.4 degrees west. How far is it from the rock to the tree rounded to the nearest tenth of a yard? Okay, reading all this, trying to keep this in your head, you're like, confusing. So let's draw a picture. Okay, so there's a river, there's a tree on one side of this river, flowy river, and then there's a rock on the other side, due west, right? So remember, never, tree is on one side, due west of a rock. So the tree is west of the rock. So the rock is directly over here. Rock. From a stake 19 yards north of the rock, so here's the rock, we go directly north, which means absolutely up. There's the stake, and we know that that is exactly north, so it's perpendicular to rock, and that was 19.0 yards away. The bearing of the tree to the stake now. The bearing of the tree, so it says from the stake, the bearing of the tree is this. So the stake is now kind of our origin, and now we're looking at south, which means down, right? Never eat soggy waffles. South is down, so here's the stake, and we're looking at the bearing from the perspective of the stake. This is really important. So south, which means we're going down, which means we go down this line, and 19.4 degrees west. West is left. So what that means is this line from the stake to the tree, I'm just going to put little ending points on everything. This line from the stake to the tree is 19.4 degrees, has an opening, right? South, 19.4 west. Okay, remember, think that grid that we had in our mind from the last slide. How far is it from the rock to the tree? Rock, tree. Now these guys are due west, right? Which means they're exactly 180 degrees across from each other. The stake was due north, so if that's 180 and that's due north, then I have a right angle in here. Actually, let me switch that color. That implies that this angle here is a right angle. Now, if I have a right angle, there's a lot of like trig magic I can do now. So now we're basically done with the bearing stuff, and now we can jump into trig. So I'm going to take this triangle that I've formed over here, and I'm going to lift it out. So now we're not talking about trees and rocks and anything anymore. We just have a perfect right triangle. And I know one side of my triangle is 19.0 yards, and I know my angle here is 19.4. And what I'm trying to find is the distance from the tree to the rock. So I'm trying to find this leg of my triangle down here. So now I've lifted this scenario up. I've put it in only terms of right triangle speak. Now I can use what I know about right triangles to solve this problem. I'm just solving for a missing side now of a right triangle. So from this angle, I have an opposite side and adjacent side. So tangent of my angle is equal to opposite side over adjacent side. Okay, multiply both sides by 19 times tan of 19.4. That is equal to x. We throw that in the calculator and we want to the nearest tenth of a yard, which just means 1 decimal point. We would get 6.7 yards. So which means that distance here we just figured out is 6.7 yards using a combination of trigonometry and what we know about bearings of lines. All right, let's do one last example, and this last example is going to be a little more complicated than this one. Okay, so boats. So remember, bearings of a lines deal with directional things. So you're going to see a lot of travel, navigation, and bearings of a line. A boat leaves the harbor entrance and travels 26 miles in the direction of north 48 east. The captain then turns the boat 90 degrees and travels another 20 miles in the direction of south 42 east. At that time, how far is the boat from the harbor, and what is the bearing of the boat from the harbor entrance? All right, what I'm going to do for this, because this is highly visual, I'm going to plop in my north line, and I'm going to plop in my east line. Okay, and then just, that would be south, that would be west, but these aren't going to be super relevant. My north and my east line are going to be really important here. Now I'm going to draw. So a boat leaves the harbor entrance. So the harbor entrance, which is our starting point, so we're going to make that our origin, travels 26 miles in the direction of north 48 east. So I go north, I know I'm going 48 degrees into the right because I'm going east. So that means that I have, let's see, right down the middle will be 45, so a little bit further than right down the middle. And it doesn't go on forever, right? I know, so what do I know? I know this angle that was formed here is 48 degrees because we went north 48 east, right? And I also know that the length of this line that I just drew is 26 miles because we went in that direction for 26 miles. So I currently have this information from my first sentence. The captain then turns the boat 90 degrees. This is important because it means, hey, I'm making a corner here, right? The captain turned 90 degrees and travels another 20 miles in the direction of south 42 east. So another 20 miles. So we'll go like that. So south 42 east. So from this point, I would go south, which is directly down, and then 42. But they already told us that he turned about 90. And I knew we did 90 in this direction because of the east, right? So I know I have a 90-degree angle here, and that's going to be extremely helpful. At that time, how far is the boat from the harbor entrance? Well, remember, this was the harbor entrance down here. So how far is the boat? My boat is now out here. Here, boat. And this is the harbor entrance now. So how far is this distance? Well, let me label it x, because that's what I'm going to try to figure out in my right triangle. You can see I have two legs of a right triangle. I'm trying to find a third. This is going to be some Pythagorean theorem magic. And then the other question is, what is the bearing of the boat from the harbor entrance? So I haven't used blue. So the bearing of the boat from the harbor entrance, well, we know it's going to be north, and we know it's going to be some degrees east. So the question is, what is that whole angle? Well, this whole angle would be this, which would be 48, right? I know this amount of angle is 48, so my question is, well, if I can figure out this amount, then I can add those two together and I would get the whole angle for my bearing. So I need to figure out what this angle is here, what this theta is, because again, I can add those two together and I would get the whole bearing here. So two things that I need to do. So the first, let me do Pythagorean theorem to figure out what x is. So one leg squared plus the other leg squared, x is the hypotenuse, equals x squared. Square these guys, add them together, you're going to get 1096. Let me just double check that so I'm not saying incorrect things. 1076, I'm glad I checked. Equals x squared. So we square root that. And how many significant digits do we have? 2, 2, 2. So I need only two significant digits, so I got to round this off. So this is going to be 33. So I now figured out that x is equal to 33. Great. So how far is the boat from the harbor entrance? Well, it's 33 miles. So I answered my first question. The second question is the bearing of to the harbor entrance. So now I have to figure out theta. So this is my second part of my problem now. Well, I have a right triangle. I'm just missing an angle. This sounds like some inverse trig. I have all sides of my triangle now, so I can just use my favorite trig function. I'm going to go tangent. So tangent of theta is equal to the opposite side of theta over the adjacent side of theta. I do some inverse trig. So I take now inverse tangent of that, 20 over 26. Throw that into the calculator, and our theta is to only 2 significant digits, 38. But I'm not done, right? All I did was I found theta. So the bearing is going to be 48 plus 38. So that was the distance. So now I know the bearing now is going to be this direction over here. So I went north first. The whole degree here is going to be 48 plus 38. So 86. And then in what direction did I go? I went east. And now I'm done. I answered both questions with the correct amount of significant digits as well. So that's the end of the video. If you guys have any questions, please, 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 please don't hesitate to ask. Bearing of a line stuff is usually new for everybody. So my suggestion is get whatever notes you took from this video and go practice. All right, I'll see you guys next time.